Hello, everyone. It just dawned on me that you may have been listening to my music selection. I had that going, but maybe Zoom was sharing it. Who knows? Welcome to Office Hours. A bit of a special Office Hours. Hopefully you can all hear me and see me. Sing out on the chat line if you can't. A little bit of a potentially unique Office Hours in the sense that since last time I saw you, I'm now fostering a dog, which is just over at my left on his little bed. So if we can... a pseudo unwelcome guest in the middle of the office hours. My apologies, but he's recently a rescue dog from a kennel, so he has no idea what even living inside is like. So he's got a few idiosyncrasies, but hopefully I've walled myself enough off in my little office space here that he won't come visiting. Anyway, welcome as always to Office Hours. Let me share my screen and we'll get into it. Okay. Hopefully you can all see the standard banner page and hopefully you can still see me as well. I'll be honest, we're very proud of Office Hours. I think I mentioned last month, we've just well into the 380, 390 mark, I think now of Office Hours sessions. Like we're almost cracking 400 sessions since we started. But let's face it, the challenges the world is currently facing means that there's a lot of virtual content going on. There's conferences everywhere. So literally every week you can literally jump into so many virtual events, which is both blessing and curse. Interesting article here on the screen about Zoom burnout or Zoom fatigue or virtual meeting fatigue. And I have nothing but respect for you as listeners because it's harder to listen than it is to speak. Because of that, I just wanted to do a little shout out here to my YouTube channel. One thing I do every time I do an Office Hours session, I carve it up into smaller chunks and edit out all the ums and ers and catastrophes and demo failures and try to put them into small, more manageable chunks so you don't have to sit in for the whole hour. So as much as I like having you here for the hour, if you are feeling a bit of Zoom burnout, head over to my YouTube channel and all the Office Hours segments will be there in more compartmentalized segments. And if I'm going to, be with the young and cool YouTube kids, I'll say, smash that like button. Don't forget to subscribe and all that cool lingo that they go with. If you're not a YouTube person, getting in touch with me was easy. You can go to Linktree/Connor. You can get me Twitter, blog, Facebook, Instagram, your LinkedIn, etc. You name it. I love talking tech, so I'm available on all your social media channels. If this is your first Office Hours with me, you'll notice the slides are down at the left. That's such that when we turn this into a YouTube video, we can put myself somewhere else, not blocking the slides, so no need to adjust your set. And let's do a couple of bits and pieces before we jump into the content. Now, this slide is actually the travel I did in 2019 to Oracle events, user group events, etc. around the world. I have the best job in the world, so thrilled with that. But of course, obviously, 2020 things are quite different. I've done minimal travel ever since the COVID-19 outbreak. However, I wanted to stress that this actually presents a unique opportunity to anyone who actually wants to be involved in user conferences, because there's a couple, for example. One is this one, the call for papers for the Latin America tour. It used to be a physical tour. Many of us would have the privilege of seeing some of these South American countries and meeting the South American user groups who are incredibly passionate. And even those for which Spanish is their first language or Portuguese, their passion for speakers, even, monolinguists like me that only speak English, is fantastic. So if you've never had a chance to do a Latin America tour, this is your chance. Because of the virtual restrictions put upon us nowadays, you could be a participant in one of these virtual Latin American tours, reach out and make some new contacts in the Latin American community without actually leaving your own home and not having to have the expense of going there. So strongly encourage that. And this one, OG Yatra. I've mentioned this many times in the past. It used to be a 7 or 10 or even 12 city India trip. And every city in India is breathtakingly different. And this year, once again, because of COVID-19, it will be a virtual event. And in terms of volume, in terms of size, in terms of passion, the Indian Oracle community is just out of this world. So if you wanted to ever do some virtual talks, once again, with in the safety from being behind the monitor, but still talking to potentially massive audiences. Yeah, once again, please submit a paper for OG Yatra. Sai, who heads the All India User Group, would be delighted to have a flotilla of speakers. And yeah, so there's no excuses now. It's not about travel. You know, if you're worried about, you know, food in Latin America or food in India, or you're worried about the culture or the laws or vaccinations, all of that has been taken away from you now. You don't have to worry about any of that. You can now give a talk to these communities from the comfort of your own home. So yeah, I'd encourage you to submit for either of those events. And I will do one shout out to an event we hosted a couple of weeks ago called Databases at Home, or the Database House Party, where we had a number of speakers. All this one hosted mainly by Oracle, with some ACE directors in there as well. I put this out. You can watch the sessions that were had on that link there, the Office Hours 8141 at the end of the link. But don't forget, there will be more coming. We're doing more of these things, more longer form events. Once again, they'll be on YouTube, but you can catch these literally mini conferences. So if you're not suffering from Zoom burnout or virtual conference burnout, we're doing our best to get as much tech content as we can to you. My final thing before I burn up too much of my hour is my standard public service announcement. If you haven't seen this graph, I'm sure you've been living on a different planet. This is all over the internet. We don't need to stress on what it is, but all I want to say is, please, whatever your local government restrictions are or enforcements or strategies are, please follow them, stay safe, stay healthy. As I said, user communities like the one that we have on our Office Hours community here, we don't gain a lot if there's no users. So shout out in particular to my friends in Italy. I think just today or yesterday, they've started easing some of the restrictions. Some restaurants are open. So Italy obviously had a very tough time back. So any friends watching from Italy, I hope you've come out of things unscathed. And obviously, if we can help in any way, please reach out. I'd love to help you in any way in terms of if you need tech content or education done, please reach out. So this session, what are we going to try cover? The containers clause, the mystery slow column, max string size, one of the cool things that came in Oracle 12, hints in the plan, and a couple of DataPump questions that came in. These questions come in once again from the community, and so I like to answer them. They're like Ask Tom Live, for lack of a better term. Once again, as always, if you want particular questions answered in video format, just go to the Office Hours page, submit a question, and we'll do our best to cover it. So let's get into it. Now, I need to warn you tonight, I've got a whole stack of demos, some of which involve bouncing around through multiple databases on multiple database versions. So they all may crash and burn, or hopefully they'll all work, but we'll see how we go. Could be a little bit variable tonight. The first one is containers. And this is the question. I get TNS errors using the containers clause. Why? Why is SQLnet even involved? Well, the answer is it's complicated. That's probably the best way of describing it. It's a bit complicated. So what I thought I'd do is we'd go through a little bit of what the containers clause is, literally in the demo, and then we'll try to talk about why you might get TNS errors and also how to work around them. This one might take a little while. So okay, I'm actually connecting to a database running under a VM. And so because of that, I need to bounce this database potentially, and Linux VMs tend to bounce a lot faster than Windows Oracle databases. So we're connecting to a Linux VM. But as you can see, this is what we've got. We've got two PDBs, PDB1 and PDB2, they're both open. And first, I want to explain what the containers clause is. So I'm connecting a system. I'm just being lazy here. Please don't ever create objects in the system schema. I just couldn't be bothered creating my own local user accounts that were common across PDBs. So I'm using system here because it's already their common user. Creating a table called demo. I'm then going to jump into, so that was in the root. I'm then going to jump into the PDB1 and create the same table there. I'm then going to jump into PDB2 and create the same table there. So I've actually got three tables called demo here under the system schema, one in the root and one in the two PDBs. If I now connect back as the root, so I'm back in the root, this is what the containers clause is. It lets you run a query against an object in all the different pluggables, including the root. That's pretty cool. So if you have, for example, especially when it comes to the world of application containers, if you have commonly described objects in multiple pluggables, you can actually query across the pluggables with a single command. That's pretty cool. So in a nutshell, that's what the containers clause does. Lets you run a query that spans multiple PDBs. As a DBA, this could be really useful for things like querying things like the VDollar performance views, or various things like any object that basically sits in commonality across PDBs. So selecting, no problems. Now I'll try, if I look at those PDBs, each one's got a unique container ID. It's got container ID 3 is PDB1, container ID is number 5 is PDB2. Now, DML is also supported with the containers clause. I'm doing an insert here, and I'm going into container ID number 3, which should be PDB1. Now, this should work, but in this case, it doesn't. I get a TNS no listener. And this is the first evidence that was provided to me from the question that came in from one of our community members. So someone's raised their hand. No open question. Okay, someone just raised their hand. I always get caught by that. So we have here the first problem involved with the containers clause. And I had to do a bit of digging with this because some of my databases, not this one, worked fine with the containers clause and some didn't. Let me go back to myself. Now, my first thought was, well, if it's a TNS error, maybe my listener is not running or there's something wrong with it. But I did a listener control status. If I scroll back a bit, I did listener control status. And you can see here's my listener. It looks like it's running. It's supporting lots and lots of services. That seems to be doing all the normal stuff that I would expect. If I look at my alert log, this is just the last 50 lines of the alert log. I can see I've got this TNS low listener. So that's the error I got. But the key thing here is a little bit further up. What happens is the way we actually do DML and some of these container style operations is over SQLnet, and we can see how it's actually doing. It's trying to connect to this gobbledygook service name on this host, which happens to be this machine. And where are we? Do I need to scroll across a bit maybe? What am I looking for? Oh, here we go, sorry. And it's connecting on port 1521. Which is the default port. Now, why can't it see my listener on the default port? Well, I'm a DBA. I'm obviously always very, very security conscious, so I never run things on the default port. If I go back to my listener status, I can see I actually run my listener on port 1519. I chose 19 because it's a 19C database. So out of the box, the containers clause needs SQLnet, needs to use the listener, and unless otherwise specified, it's always going to use the host and port 1521. So the question is, how do I let the database know that when it needs to talk to pluggables from the root via SQLnet, how do I let it know that it needs to talk through a particular port that's not the default? And this is why a lot of people probably have never seen this, because they're probably running the default ports. So I connect back to the root as sysdba. And I found this in the documentation. I'll explain where I found the documentation later on. But I can go into each of the containers. I go to PDB1, and I can do this clause, alter pluggable database containers port equals 1519. And just for completeness to show you, although it was correct already, I also can set the host. So it's actually, I set the host and I set the port for this particular container. I then go into PDB2 and do the same thing. I'm letting the root know this is how you get to me in a containers clause when it's required. Don't forget, we saw that doing the select star with a containers clause was fine. It was only the DML in this particular case. So I've set these, can reconnect as system admin, and I'll try to do my DML again with fingers crossed. And guess what? It's not going to work. I can immediately tell from the length of time it takes. Now, I have actually done the correct settings, but I need to do more. Let's try bouncing the pluggables. So I'll go to PDB1, close it and reopen it. I'll go to PDB2 and I'll close it and reopen it. So they've both been bounced now to hopefully pick up those new host and port settings. Connect to system admin, have another shot at it, and sadly, it still doesn't work. My understanding is is that if you have changed that host setting, change that port setting in order to convey to the listener that you need SQLnet to convey through a different port, communicate through a different port, then the only way they get picked up is for the entire database to be bounced. Now, I've set that running. This will take about 60 seconds, unfortunately, because that's how Windows machines go. And obviously, I'm recording the Zoom session, so that's going to slow everything down as well. But while we're doing that, let me jump back to the slides briefly, and we'll come back to this. If I go look in the documentation under Alter Pluggable Database, in all the versions of the documentation, there is an Alter Pluggable Database and a PDB settings clause. There's a set command here, but you won't see anywhere in the documentation. There's a set container map, there's set default, a few other set clauses. But unfortunately, in the documentation, it has yet to catch up with this. In Alter Pluggable Database, there is no reference in any of the syntax guide for set containers host, set containers port. So that's why this one took a little bit of a while to nut out. Now, if it's not the documentation, how did I come across it? There's another technology sitting around inside the Oracle database called proxy PDBs. A PDB can serve as a proxy to another. And the way proxy PDBs work is they communicate over SQLnet. So it's actually in the proxy let me start that sentence again. It is in the proxy PDB settings that you actually have this. You can set the host clause and you can set the port clause. So it was actually tucked away in the multi-tenant guide. Was the hint that this syntax actually existed and that it was required for proxy PDBs. It turns out that DML through the containers clause must be doing some sort of similar proxy style of operation. Let's see if my bounce has come. Yep, so my database has now been bounced and we're back and running. Let's give it another go now that I've bounced the database. I connect to system admin and voila. Now that the database has been bounced, the entire database has been bounced, it's picked up those settings for host and port. And I can see I had two pluggables. One was container number 3, which was PDB1. One was container number 5, which was PDB2, and both inserts work. I commit those changes, I do a select, and you can see that actually in each of the pluggables now, in pluggable number 3, which is PDB1, pluggable number 5, PDB2, I've actually got a row in each table. So if you encounter a TNS listener error when trying to do the containers clauses, whether it's DML or select or whatever, it's actually being implemented in some way under the covers, similar to the way we do proxy PDBs. You need to have your host and port set. Let's continue on a bit and look at some more examples of this, because I'm sure many people aren't using the containers clause. Let's see the way it works and some of the things you have to be aware of. One of the things you'll see is a delete from a containers clause doesn't span containers. You saw on the previous screen that we had 2 rows across the 2 tables in each of the pluggables, one in each of the pluggables. Yet a delete from containers deletes nothing. Deletes must be qualified with a container ID. They need to reach into each container to do a delete. And you might be thinking, well, I'll just do an in clause. I'll do where container ID in 3 and 5, because I know that's my 2 pluggable databases. That won't work. That's an unsupported condition. Let me check the chat. Someone's saying, will there be resources to this broadcast after the meeting? Yes, they will. I'll obviously make this video available and I'll make these scripts available as well. So thanks, Jerry. Where was I? Oh, yes. So a delete from a containers clause, if I'm trying to access all the pluggables by using con ID in, something like that, is not permitted. The only thing that's permitted is to nominate a single container ID. So I can do delete from system demo where container ID equals 3, pluggable number 1, delete from system demo where container ID equals 5, which is pluggable number 2, and then I can commit and the rows are gone. So that's the restriction on delete. You have to dive into each individual container. Pluggable. Now that I've deleted those rows, let's put those rows back in. So I insert a row into pluggable number 1, container 3, insert a row into pluggable 2, which is container 5. Let's do a query. I don't see anything. Now, why is that? Once again, don't forget, pluggable databases are like distinct databases in their own right. So we've gone across, we've done effectively a distributed transaction. And so from the root, what I can't actually see is uncommitted transactions. It's like looking into different sessions. I must commit all the changes. And that's effectively like a distributed commit, like a two-phase commit. And once that's done, now my query can reach out to the individual pluggables and actually pick them up through the containers clause. So it's not just a case of, oh, I can just whack in a containers clause and everything works exactly like normal. It is a syntactical convenience for you to actually reach across pluggables. But don't forget, pluggables are distinct things in their own right. We are effectively doing a little bit of distributed database trickery here. What else we got here? So I've deleted those rows. I've inserted one row. So now I've just got one row. Okay, so I've cleared up the 2 rows. I'm just putting one row in pluggable number 1. So I've only got one row in my containers table. This is so I can do a little bit of PL SQL on it with some single row fetches. Let's start with a real simple query. I'm doing declare a ref cursor and in PL SQL, open a ref cursor for select star from system.demo. No problems there, that seems to work fine. The reason that works fine is of a PL SQL optimization. And in fact, the database does this in many places. If you just open a cursor, all the database does is do a very loose parse check on that, because why bother? Why bother doing any work to open a cursor? Because unless someone does the first fetch, why bother? If they never fetch from it, I've saved myself some work. So yes, this does work, but we're actually not doing a great deal here. Let's actually go ahead and do something. So this time I'm going to open the ref cursor and I'm actually going to fetch. Now, as we know, that select star from the containers gives me the con ID column, which has the pluggable number, and it has the column X, the one column we created in our table called system.demo. So I'm going to fetch select star and fetch them into these 2 columns. Let's see what happens. Oh, I'm missing a pause. Well, as I said, there's a bit of variability in our scripts today. What happened there, unfortunately, it flicked off the screen, is we actually got an error. And the error was, it said you were trying to fetch a single column into 2 result variables, because PL SQL does not know about the con ID column, even though it comes back when you do a select star from the containers clause. And hopefully this one doesn't clear the screen, because this was just a further example of that. I'm doing select con ID X from containers system.demo. I get an error, which is actually similar to what you would have seen on the previous screen. The error is at compile time, the PL SQL engine doesn't know about this thing called the con ID. And I don't know the specific internals, but my guess is what's happening is containers.system.demo returns to the calling environment just the contents of the system.demo table, just that single column called X. And then the containers clause is responsible for prepending the con ID column so you know which pluggable it came from. My guess is the PL SQL engine compiles that before the containers clause has actually executed. It's at execution time we add the con ID column. This is my hypothesis, unproven, but as a result, PL SQL struggles. It doesn't understand this con ID column because it doesn't exist in PL SQL's eyes yet. So interestingly, if I just refer to the column, the actual true column in the table, then PL SQL is fine. If I actually want to reference that con ID column, so here's the exact same example we had before that disappeared off screen, but notice the key thing here is I've made it dynamic SQL. So I'm not actually compiling this particular SQL, I've made it dynamic. So it's actually a string, I'm doing select star, so it should give me the con ID and the X column, and I can fetch it into C1 and C2. Let's see if it works, and it does. So if you're using the containers clause in PL SQL, there's a very good chance you're going to have to revert to a little bit of dynamic SQL in your code, because the con ID column doesn't seem to be available to the PL SQL compiler until actual execution time. Here's one that's maybe not so good. So I'm back in the root container. So the container ID is 1. I'm going to use a PL/SQL insert command now, but I'm going to use a bind variable. So I'm going to declare I want this to go into container number 5, which happens to be PDB2. And that bind variable goes into my insert statement. I'm saying insert into this container, but I'm nominating the container ID, which is this, which should be the value of 5. This should go into pluggable number 2. And as we can see, it ran just fine. Let's see where the value of 20 ended up. It ended up in container number 1, the one I'm currently in. I'm pretty sure that's a bug, but you can see at the moment, when it comes to PL/SQL and the containers clause, you're going to have to take a little bit of care. There's a few issues around containers. Other than that, the technology is pretty cool. For a DBA, if you're managing a single database, single multi-tenant database, which has hundreds of pluggables in it, and if you're running, any of our sort of engineered systems, they can scale out to ridiculous amounts. You can put a whole stack of pluggables on there. Being able to very quickly scan across all those pluggables rather than having a bazillion scripts that do alter session set container equals pluggable 1, pluggable 2, pluggable 3, pluggable 1,000, or create database link that points to pluggable 1, pluggable 2, pluggable 3. The containers clause is a very, very nice syntactical convenience to let you span all of them. Just be a little bit careful when you're dealing with PL/SQL. And heading right back to the first part here, if you get TNS listener errors, then make sure you do your alter pluggable database, set containers host, set containers port, and that's going to solve your problems. So that's pretty cool. The mysterious slow column. Now, this obviously needs a little bit of elaboration as to what the issue is here. I have a virtual column which is expensive to derive, but depending on what query I'm doing, what kind of query I'm doing, sometimes the queries are really, really fast, sometimes are really, really slow. What is going on? Now, there's a very, very simple answer to this issue, and this is what I thought was the issue. And I stress what I thought because we're going to explore this a little bit further in a second. But I thought I'd explain what the most common cause is before we go on to the slightly more complicated one. So I've created a table called T. It's going to have 100 rows in it. Keep that 100 in mind because it's going to be important when it comes to our timings. Now, rather than creating an expensive column that does a lot of computational, I'm going to mimic that by creating a function called virtual column. It takes an input of C and returns C. It does nothing. But the cost of executing this function is that we're going to sleep for 1/10 of a second. So every time we call it, we lose 1/10 of a second. Now I'm going to add that function as a virtual column, hence the function's name. Just a quick return back here. Obviously, if you want to use PL/SQL functions in a virtual column, you need to define them as deterministic. Given that this function returns whatever is passed to it, I think we can safely say it's deterministic. So I've added this column called slow column, and it's this call to this function. So 0.1 of a second for every single row that we access. So I've turned array size to 10, so we get 10 rows at a time. And as you can see, as I select it, each 10 rows takes a second. And that's fairly obvious because 10 rows times 0.1 of a second equals 1 second for each batch. 100 rows takes about 10 seconds because there's 100 times 0.1 of a second. This is the most common reason that obviously a virtual column could slow you down. Now, in terms of answering the question of how come some queries are slow, some queries are fast, well, the optimizer is pretty intelligent. If I do select C1, C2, C3 from T and don't make a reference to the virtual column, we get instantaneous response. I never had to call that function, therefore I never had to incur that timing penalty. And it's pretty smart. Even if I have an inline query which says go get all the columns from T, including my slow column, but then wrap it with an inline view to just, I want C1, 2, and 3, the opt is smart enough to actually work that stuff out. And even if I have things like order by and stuff like that, right? It's all nice and quick. That's pretty cool. Even if I take this slow column and add a constraint and say, I want to make it not null, that takes 10 seconds because I need to actually read every single row and apply that function and just see if the return is null, which it's not. Now the column is defined as not null. And that's cool because the optimizer is now pretty smart. So if I do something like this, select all the columns, select star from T where slow col is not null. So I'm actually making a reference to this virtual column. That's instantly fast as well, because if I scroll back, the optimizer said, oh, that is defined declaratively at the table level via this. Therefore, that's an always true condition. I don't need to evaluate it. I don't need to go near that slow column, and I get the instantaneous timings. Flicking back to my slideshow. So they are the most common reasons that you see differing performance characteristics if you have an expensive virtual column. It's the optimizer lending its intelligence to you, doing its best to avoid needing to reference the expensive to calculate virtual column. This is what I thought the issue was. In the process of toing and froing with this person about their issue, I said, oh, here's some examples of where it's going to be fast, going to be slow. And they came back and they said, thanks for all that information, but that doesn't seem to be the case of what we're seeing. We're seeing something different. And so we built another test case, which I'll show you now, which is quite interesting. This time, I'm going to create a table called T. It's going to have 5,000 rows, lots and lots of rows. Now, rather than adding my function here, I'm going to add a CPU-based expensive virtual column. Now, this looks ridiculous, and it is. All I'm doing is taking column C3 and raising it to the power of 2, and then finding the square root, which brings us back to C3. And then square root power, square root power, square root power. Yeah, the net result is pretty much nothing. It's just a lot of computational effort to derive this. And therefore, it's the same as the previous example. It's going to slow the query down. And we can see, this time I got 5,000 rows. CPUs are very fast, so I had to bump up the number of rows. But 5,000 rows, and I'm evaluating it, takes about 10 seconds. So it's 5,000 iterations of this incredibly CPU expensive function. That's why it took about 10 seconds to run. So already you can see me leading down that previous path of, oh, it's because you're referencing the column, therefore it gets slow. But here's where things get a bit interesting. If I do this, select star from T, order by the slow column. That seems to make common sense. If I'm ordering by it, then surely I must be querying it and getting its value. Therefore, it also takes 9 seconds. So far, we're still in the same realm as the previous demo. Let's try this one. Select star from T, order by C3. It still takes 10 seconds. Now, that's fair enough because I'm doing select star. So even though I wasn't ordering by the slow column, I was querying the slow column. So it, once again, 5,000 executions of that CPU thing. Nothing odd here. So far, I'm making the assumption or hypothesis that 5,000 iterations of this expensive computational calculation is going to take me about 10 seconds. So when I was actually investigating with this person, I said, well, let's see how much of that 10 seconds that computation is. So I did it in PL SQL, which is, in theory, surely should be slower than the SQL engine because it's all interpreted code. It's not running natively in the kernel. I'm going to do 5,000 iterations of this function. And it was near instantaneous. That's a bit weird. So then I went back to this. Let's select the slow column from T, which surely must execute this function 5,000 times in the SQL engine now. And as you can see, it also takes almost no time. So we had this very interesting scenario now. I was wrong. 5,000 executions of this expensive function actually doesn't take 10 seconds. It takes less than 0.1 of a second. So where is the 10 seconds coming from? If it's not that, how come when we do a max, it takes 10 seconds, but we select them all and it's instantaneous? How come when we do an order by the slow call, it takes 10 seconds, but when we select them all, it's instantaneous? So what's the answer? The answer is stay tuned. We don't have an answer to this yet. I've been asking around internally and some of the internal developers, and yeah, there's a lot of head scratching going on. So we've made this discovery about what is going on. Like, is that column being evaluated more than 5,000 times? Is it being evaluated multiple times per row? Is something to do with the sorting slowing it down? We don't know. We're doing some investigation at the lowest levels of the kernel. So this is one of those great office hours questions where we thought we had an answer, but we've actually revealed a new area of exploration inside the database kernel. So stay tuned, more investigation to be done, but we don't have a rational explanation for it just yet. There you go. Max string size, a very cool parameter that came in Oracle 12. I want to increase the maximum string size from 4,000, which has been there since way back in Oracle 8, to 32,767. I know that under the covers the database will be using CLOB-like structures to implement this, but is there anything I should be concerned about? And the answer is yes. So why? It's not just a case of everything getting bigger and more beautiful. The vast majority of your experience will be that, the ability to suddenly have nice big varchars. But there's a couple of things you need to be aware of. And part of that is we're fixing what I call a past omission. And to help explain that, I'll go through a demo first, and then we'll come back and explain this statement. So this is our demo to look at the maximum string size. I'm creating a table called T1, and it's got a couple of columns, varchar to 2000 from back on the good old Oracle 7 days, and varchar to 4000, the current maximum if you haven't set max string size to extended. I'll create a couple of indexes on those columns because even though they're large string columns, sometimes we want to use some indexes on these columns. Something's on the chat line. Okay, thanks Terry for joining us. We'll see you again soon. Now I'll create a table T2, which is probably how we're meant to create things in a global marketplace. I'm using the varchar to 2000 char, var1000 2000 char syntax, because just because I can store 2000 bytes doesn't necessarily mean I can store 2000 characters, because some characters require multiple bytes to be stored. Once we get into foreign languages, accented names, etc., we obviously want to be able to cater to that in our database structures. If you've been on Office Hours website recently, you would have seen we're doing some Office Hours in Arabic. And yeah, the font just takes care of itself because we use UTF-8 throughout all of our databases. So this is good practice when you're creating tables in any modern database that will be used internationally, because you want to actually have character semantics, not byte semantics. And I'll put some indexes on that table too. I'm going to connect a sysdba on this database. It's connecting, that's the database I'm connecting to. This is the one that's running on Linux. Currently, we can see the max string size is standard. That's why those previous commands worked fine, because I'm capping them at 2000 and 4000. I'm not even venturing into the 32K mark yet. But I want to. That's going to be my next project. I'm going to have some nice big strings. So I'm going to set my string size to extended and bounce the database. So we'll shut down immediate. This is why I'm doing this one on Linux, because the shutdown immediate should be faster and the startup should be faster. He says bravely. So we've shut the database down, and because I've set that parameter, now I do a startup. Come on, laptop. Come on. Connect, do a startup. It looks promising, and hopefully we'll get something bad happening. Bingo. This is the first thing I wanted to stress to people when you're moving from max string standard to max string extended. You don't just set that parameter and bounce the database. there's more to do. We actually have to make some updates to the data dictionary in order to accommodate this. So we shut down immediate. I didn't need to because it already shut down. Reconnect to sysadmin. Start up in upgrade mode, because when you've set that parameter, the next step needs to be start up in upgrade mode. Once you've started in upgrade mode and the database is open, we need to run this script, utl32k.sql. It adjusts the dictionary to cater for this new string sizes. And off it goes, does little bits, and it's done. Shut the database down, start it up again. You can see why I was using a Linux database here, because my Windows one always takes so long to start. Shut the database down. Now that I've run utl32k to fix the dictionary, and I've got max string size set to extended in my SP file. Come on, database, shut down. Come on. Thankfully, we'll be able to edit this out of the YouTube video. Come on. It's not that hard. Not that hard. Phew. Surely this justifies a bigger, powerful PC for me. I need to speak to my manager. So the database is shut down. Reconnect is that. And I can start up, finally. This will start the database up. I've run that script. My SP file is set to extended, and the database will open without incident. And so far, everything looks fine. And if I go ahead and create tables now, I can create them as varchar to 10,000, 12,000, etc. But one of the things I don't like about that script rerun is it does actually produce warnings, but they sort of come flying out just in the middle of that processing. They're actually somewhere halfway through it, and they went flying past. We didn't particularly notice any. And they're critical warnings. What we need to do is look at this table here, sys.utl32k_warnings. It's created as part of that script. Ideally, it will return no rows to you. That means everything went fine. But in my case, it says here, I have a couple of indexes, and it says they must be dropped because of maximum key length. That's a big deal, because obviously dropping indexes means I have some architectural changes I need to take care of. And the question is why? Why do I need to drop? Why is it enforcing that I had to drop indexes? This is why. Let's look at our two tables. We had T1, which was created as varchar2 2000, varchar2 4000, just in terms of bytes. What that means is the definition of how many characters we can hold is 2000 and 4000. And internally, that's how many bytes we allocate to them. T2 table was different. It was defined with character semantics. And what we've done is we said, okay, if you're asking for 2000 characters or 4000 characters, then internally, because this is a UTF-8 database, that means the number of bytes we might require for this column could be up to 8,000 for a 2000 character column and up to 16,000 for a 4,000 character column. We might need 16,000 bytes potentially. Now you might be thinking, well, if I had 4,000 characters back in max string size equals standard, how was this allowed? Because it would have been capped at 4,000 anyway, because we simply couldn't go above it. And this was a bit of a cheat we had. We used to simply say, yes, you can have 4,000 characters. It's capped at 4,000 bytes. So when you actually put, for example, 1,500 characters in there, which happen to be multiple byte length characters, we'd simply say you're out, you run out. So max string size of extended actually lets you now have the genuine 4,000 characters, even if they're multi-byte characters. We will actually consume up to 16,000 bytes, for example, to give you a genuine 4,000 characters. We've actually corrected a bit of a lie that we had in the past. We said, yes, you can have 4,000 characters, but in reality, you might not get it because we were simply capped at 4,000 bytes as well. So we've actually remedied that now. We've solved that problem. You genuinely get your 4,000 characters. Woohoo! The price of that, though, is that 16,000 bytes and 8,000 bytes is exceeding the length, the maximum key length you're allowed to have in an index. An index in an 8K block size can only have a key of about 6.5K. This conceivably will exceed 6.5K. You cannot have indexes on these columns, unfortunately. And that's why it's not like they just must be rebuilt or recreated. They literally must be dropped. So if I create these tables and try to create indexes on them, I've dropped it and recreated it, you can see from that point onwards, that's my maximum key length. I literally cannot create an index on them anymore. Help is at hand. You can actually, if you're doing equality-based indexes, create indexes on hash values. I'm not going to do it in this office hours simply because Chris Saxon did a very good session on it a few weeks ago about using the standard hash function to index large character columns. So you can check out his office hours session for that. I didn't want to repeat that work, but something to be aware of. When you go from max string size of standard to extended, be aware that you may actually have some index issues that you need to cater for. Conversely, we have actually fixed a bit of a past omission. We used to say, yes, you can have 4,000 characters, whereas in fact, we were, you could say, lying. You didn't always get it. Now you genuinely get the full size of characters that you were after. So that's pretty cool. Hints. I saw your video. If the person who asked this question is on the call, thank you for watching my video. I saw your video where you use a use hash hint, but the query does not use a hash join. And it's true, there's a video out there. I show that there's a use hash hint, and yet the database still does a merge join, and we dig into why the optimizer does that. You explain why, but the person's saying, well, how do I get that information? You know, it's not just good enough to have someone on the video going, oh yes, this is why. I need to be able to understand this myself. And that's a very valid point. Before 19C, if you're trying to work out how the optimizer is dealing with hints, the simpler way of explaining that is it's hard. And we'll come back to looking at how you can get a little bit of information, but it's hard. Another reason to go to 19C is we've dramatically improved the way we can report back to you as a developer or DBA, the way we're digesting the hints you put in your SQL queries. So I've got my table here called scott.emp. I'm sure everyone's familiar with this scott.employee table. And just to show there's no smoke and mirrors here, I do indeed have an index called emp.pk. We're going to refer to that in some examples coming up here. Now, I'm not using any hints in this first SQL. I'm just doing this to explain one of the cool things you can do with any SQL statement in the Oracle database is once you've run it, you can run select star from dbmsxplan.display cursor. And it shows you the plan that was used for the previously executed SQL statement. And you get all the normal stuff. The predicate information I'm not interested in, so we're going to strip that out in following examples. But the key thing is here is we get the SQL statement and we get the plan. We're now going to start throwing some hints in here and actually see what the actual database does with those hints using a cool piece of tech that came in 19C. So let's start with the obvious one. Let's start with a totally false fictional hint. I wish it was a real one, the go faster hint, but there is no such hint. That's obviously an incorrect hint. I run that and then I run this. I've changed display cursor to remove the predicate. I'm not interested in that. And I'm adding this thing called the hint report. So I get the normal plan, but now I get this thing at the bottom called the hint report. And this is cool. It says E means an error. And the ones in error were select statement number 1, which is this one here. Ooh, it's just disappeared off. Select statement number 1. There was an error in the hint called go faster on line 1. So that's pretty cool. Straight away, we get this really useful information saying, yes, that hint was in error. There's no such hint. So straight away, I know that go faster, bad hint. Let's use something else. How about the use hash hint? We know that's valid, right? Same problem. Use hash is a valid hint, but I haven't phrased it correctly. Use hash requires some brackets around it and a target of the use hash hint. So it says, yep, you've got a syntax error in your use hash hint, E for error. So once again, another example, but probably a more realistic example of where we might go wrong. How about this one? I'm doing select full on the employee table, Scott.m equals 10. It says, yep, I used the employee hint. I have a dash here, which simply means there's no status, it wasn't an error. And yes, I actually did use your hint called full on the employee table. It is a valid hint, Scott.emp and the employee table in there, a valid hint, and it was used. How about this one? This one's an interesting one. If I do full Scott.emp from Scott.emp, well, if we look at the syntax inside the documentation, we'll see that that's actually an invalid hint. We're actually doing full on. That is not accepted. You can't use the schema name inside the hint. And we get this. What's quite interesting is we get no hint report whatsoever. That's an interesting one. I think we should actually get some sort of report that it wasn't used or it's invalid. I'll take that up with the optimizer team, but that's one I discovered today, that it doesn't seem to report anything. That's perhaps an oversight. Let's look at this one. I want to use an index on the employee table. And this one says, yes, once again, it's valid. I used the index on the employee table. There's no errors or no flags there. It says, yep, I used it. So far I've had the obvious ones where it's invalid and the ones where the hint is actually used, but it's even better than that. Let's look at this one. I'm saying use the index on the employee table from Scott.emp, and it says, it was unresolved. Why? Let's look at my query. I'm doing select index on the employee table, but I gave the employee table an alias. If I use an alias, I have to use that inside the hint. So this is saying this hint was unresolved. I couldn't find something called EMP in this hint. I get a flag of N. So not only is it syntax errors, it actually is things like this, where the hint didn't make sense in the context of the query as was written. How about this one? I want to use the employee primary key index. Same problem. Because the employee table is aliased of E, empk doesn't work. I would need to have an E in there followed by empk. So it's unresolved. How about the one I talked about in a previous video? This is the one where I've said, I want to use a hash join into the table called D. When I look at the table, I did a merge join. Why is that? It says this hint was unused. U is unused. I didn't actually use the hash join hint. Now, the subject is that for another video, but that is a hash join into D only makes sense if I didn't start with D. In this case, I started with D, so using a hash doesn't make any sense. If I add the leading hint, which says start with employee and then hash join into D, I get my hash join as I wanted, and it tells me, yep, I used on line 1, I used the leading hint to go into the hash join, and I used D as the target of the hash join on line 3. So you can see there's some really cool stuff here. It's telling you where they were used, where they're in error, where they couldn't be resolved, where they were unused. That's pretty cool. And for example, even this one, it's the same example, start with the employee table, hash join into D, but also use a nested loop. Doesn't make any sense, and I get that information. Yes, I use the leading hint. Yes, I use the hash join hint, but the use nested loop hint was unused in this case. So it actually digs down on a hint by hint basis. And we can make interesting discoveries as well. Like, what if I have a logical contradiction? I'm saying down in the inline view, the query block name is X. I want to use a full table scan. But up here, I've said in the query block name called X, which is this query in here, use an index. So I've got index versus full. And we make this interesting discovery. We actually did a unique scan. So we actually used the index hint, and it looks like a hint on the outer overrides the inner, and it actually says hint overridden by another in the parent query block. So not only do we get some good hint reporting, we actually make an interesting discovery here that we actually have hints in the outer block will override those in the inner block. Very, very cool. So that's hint reporting, some very, very cool stuff. If you don't have 19C, then the only thing you really can do is dig around in the 10053 trace. And it's nowhere near as good as that, because this is the kind of things you would see if you're running this on, say, 12.1, 12.2, or 18. Here's the example of the use hash. You have to dig around in the trace in the dumping hints section, and it looks like this. It says errors 0, resolved 1, used 1. 0 means okay, 1 means not okay. So it says there were no errors, but I couldn't resolve it and I didn't use it, the use hash hint. In this one, same thing. It's a valid hint, but I couldn't resolve it, I couldn't use it because there is no index called PK in this. It's emp_PK. And if you give a totally invalid hint, you get this wonderful piece of information. You get nothing. That's about it. Now it's 9:58. We do have a couple more. Let's go 3 or 4 minutes over time. Let's do that, okay? I'll understand if you need to leave, but we'll go a few minutes over time because these two are actually quite snappy and fast. Quick drink. DataPump. The first question was regarding migration. I've seen all the migration to cloud options that you offer. We've got zero downtime, move to ADB. It's a suite of tools that, or Golden Gate, etc. But they all pretty much sit on top of Golden Gate. Golden Gate fundamentally means you need to unload all your data and then reload it into your cloud-based database equivalent, which obviously will involve some resource consumption and time and effort. Why can't I just give you a backup? And it seems trivial, doesn't it? Just give you a backup. The first reason for that is security. And that is we do not permit a single database in our cloud that we manage to be unencrypted. And so if your database is unencrypted on your current premises, we won't let you put a backup of that on our cloud because it's unencrypted. That's a security risk, not just for you, but for across the board. It looks very bad if Oracle were to have a security breach and someone stole unencrypted data. So one of the cool things is we're not like some other platforms where basically we leave security just to the whim of what you want to do. This is, we do not let you have a database unencrypted on our cloud that we manage. So that's the first reason. Now, someone said to me, well, that's all well and good, but you have an online TDE conversion facility. You can actually go from an unencrypted data file to an encrypted one online. Why couldn't we send a backup up the line and then you do the TDE out there for us? And therefore it's encrypted by the time it becomes available to us. That comes to the second reason, which is risk. If we took an entire backup of an entire database from someone, brought it up and just started running it on our system, who knows what's inside that database? Maybe you've hacked some of the system packages. Maybe you've loaded some Java routines that do destructive things to the database. Maybe you've hacked some of the ACLs, the security things that let you get to the outside world. It would be an open invitation to hackers to sign up for a cloud account, create a very malicious database, send it up to us and say, hey, can you please switch this thing on your cloud? That's the second reason. So all these things are designed about protecting your interests. We don't want your data unencrypted because that's a huge risk in terms of you in case you get hacked. And we don't want to bring up a potentially compromised database and run it on a server that you, for example, you might be running on. You know, we have shared infrastructure, you know, depending on which cloud account you're using or cloud option you're using. We wouldn't want someone else not just to be a noisy neighbor, but to be a killing, murderous, slanderous neighbor on your database because they loaded up a very compromised database. So there are very good reasons why we do it, and all of them are designed to benefit the integrity and security of your data. Another DataPump. DataPump in terms of its actual usage. And this is a nice simple one. It came in as a question I thought would be a nice way to finish off because it's a nice easy one and hopefully explains some things nice and easily. I have a DataPump export with all the data included. I need to load just the definitions and not the data into a different schema in a different database. How do I do it? And you'll be pleased to know DataPump caters to this, and we'll finish off with this example. So I've got a user called Demo. I'm getting rid of him. I'm going to create him now, and he's just got the normal privileges, and he's got privileges, table space privileges on the user's table space. to have a nice set of information that I can data pump out and load in the Scott schema, which is going to be our source, I've got the Scott tables, obviously, but Scott by default doesn't come with any PL SQL. So I thought we'd put a little PL SQL routine in there just to make sure we pick up that as well. And so this is how DataPump works to actually export an entire schema. Most people are very familiar with this. It's simply XDP, username, directory, dump file. And because I logged on as a particular account, not a DBA, it simply unloads that entire schema. It runs relatively quickly. Unload a few tables. Chug. Come on. And we're done. How do we get it back in? I'm importing as a DBA and I simply remap the Scott schema to demo. That's, oops, let me get my password right. And so this is your stock standard DataPump import. And it says it imported 14 rows, 4 rows, etc. Now, this isn't what the first person asked. They asked for just the DDL. But I thought we'd start with this one, just the most simple, straightforward export import showing how we go to a brand new schema. And this could even be in a brand new database. We use the remap schema command. If I go to my demo schema, you can see I got all the information from the Scott schema. I got the tables, and there's 14 rows in the employee table, and I even got the PL SQL routine as well. The entire lot was copied over. Now that we know how to remap schemas, let's tackle the question that came in, which is how do I do it with just the data? So I'll drop the demo user, I'll recreate him. There's my same Scott sample prop. I didn't need to recreate it, but it's still there. Let's do my import again. And all I've done, I've still got the remap schema, but all I have to do is say, I just want the metadata. That's all I have to do. And off we go. And it'll once again import from Scott into demo, all the objects. This time we don't see a list of the tables, etc., and the rows. But I go into my table, and here's the thing that's important to realize. Yes, I created all the tables. I even created the statistics that came across from the export of Scott. So it actually says the tables are fully populated in terms of their statistics. But I've looked at the data, it's actually empty. But it's important to realize that there is this discrepancy here between reality and the statistics because the stats come over. You can actually control that as well in an import, but we won't do that. And your PL SQL source is copied over as well. On that note, we're done. And we only went 5 minutes over, which is probably a record for me anyway. Thank you very much for attending. Always a pleasure to have you on. As I said, all these office hours tidbits will be available on my YouTube channel, plus all the previous ones I've done. And we'll edit out the slow shutdowns and the slow startups and me missing my scripts, etc. So we'll edit all that stuff out so it's nice and compact for you. So please subscribe to my channel. If not, please stay safe, stay healthy, and we'll obviously see you on a virtual conference again somewhere soon. And yeah, please reach out to me on Twitter, stay in touch, and good night for tonight. See you again soon.